Something is crossing our solar system right now. Not from here, not from anywhere near here. It came from another star, possibly from a sun that burned out before our own Earth even existed. It has been traveling through the cold darkness of interstellar space for billions of years. And when NASA's Hubble Space Telescope finally locked its eye onto this thing, what scientists saw didn't just raise questions, it shattered assumptions. Because what they found inside this ancient visitor doesn't match anything we've ever seen in our own solar system. And that changes everything we thought we knew. There is a moment in science that doesn't happen very often, a moment when the data comes back, and even the people who built the instruments don't fully know what they're looking at. That moment happened on July 1st, 2025. A robotic telescope in Chile, scanning the sky as part of a planetary defense early warning system, caught something moving against the stars. Something moving too fast. Something moving in a way that immediately told astronomers, this object did not belong to our solar system. Within days, it was confirmed. A comet had been discovered traveling at approximately 137,000 miles per hour when first detected, already inside the orbit of Jupiter. And the scientific world held its breath. They called it 3I Atlas. That name alone tells a story. It is only the third known object ever observed passing through our solar system from outside it. Third, in all of recorded human history, with all of our telescopes and satellites and centuries of sky watching, we have only ever caught 3 visitors from beyond our own cosmic neighborhood. The first was Oumuamua in 2017, a strange, cigar-shaped object that moved so oddly some scientists couldn't stop themselves from whispering uncomfortable questions. The second was Borisov in 2019, confirmed as an interstellar comet, fascinating but somewhat familiar. But this one, 3I Atlas, would turn out to be something else entirely. And what Hubble captured when it turned toward this object would set the scientific community on fire. Think about what it means to travel at 137,000 miles per hour. At that speed, you could circle the Earth more than 5 times in a single minute. You could reach the moon in roughly 2 hours. You could cross the entire continental United States in under 12 seconds. And this comet was moving through space at that velocity when it was first spotted, still decelerating from the long journey between the stars. 3I Atlas was traveling through our solar system at roughly 210,000 kilometers per hour, the highest velocity ever recorded for any solar system visitor. Read that again. The fastest interstellar object ever recorded in human history. And Hubble was about to give us our first real look at it. But here's where it gets more complex. The speed wasn't just impressive, it was revealing. According to informed sources in the astronomical community, that breathtaking velocity shows that the comet has been drifting through interstellar space for billions of years, with the gravitational slingshot effect from innumerable stars and nebulae it passed adding momentum, ratcheting up its speed over time. The longer it traveled, the faster it became. This was not a young object freshly ejected from a nearby star system. This was ancient, profoundly, almost incomprehensibly ancient. And the deeper scientists looked, the older it seemed to get. The specific star where comet 3I Atlas originated is unknown, but its high velocity suggests it comes from the Milky Way galaxy's thick disk, a population of very old stars, making it possibly the oldest known comet with an estimated age as high as 11 billion years. 11 billion years. Our own solar system is only about 4.6 billion years old. Our sun hadn't even formed yet when this object began its journey. Somewhere in us, the ancient Milky Way, a solar system we will never visit, was building its planets and flinging its debris outward. And one frozen fragment of that long-dead process has now passed through our neighborhood, close enough for our telescopes to see, close enough for our instruments to taste its chemical breath. The implications of that are staggering. When Hubble finally locked onto 3I Atlas on July 24, 2025, the telescope was performing something it had done millions of times before, turning its lens toward the sky and capturing light. But this time, the light was coming from something nobody had ever photographed before. Hubble imaged the interstellar comet when it was 277 million miles from Earth. The telescope revealed a teardrop-shaped plume of dust around the nucleus, as well as traces of a dusty tail. That image, that single extraordinary photograph, confirmed beyond all doubt that what had been discovered was a fully active comet, not a rock, not an asteroid tumbling silently, a living, breathing, outgassing comet from another star. And this is where everything changes. Because active comets don't just look interesting. They talk. The gas and dust they release is a chemical diary, a direct readout of what the comet is made of, where it formed, and under what conditions. Every molecule that boils off the surface of 3I Atlas as it moved closer to our sun was a letter and a message from another solar system. And Hubble had just opened the envelope. But Hubble alone couldn't read all of it. Astronomers originally estimated the size of the icy core at several miles across, but Hubble's observations narrowed it down to no more than 3.5 miles wide. That's a critical detail. Something up to 3.5 miles wide, made of ice and rock and ancient chemistry, moving at over 130,000 miles per hour through our solar system. And its nucleus, its solid heart, remained hidden even from Hubble's sharpest eye. The solid heart of the comet presently could not be directly seen, even by Hubble. Think about what that means. Hubble, the telescope that has spent 36 years revealing galaxies billions of light years away, that has photographed the birth and death of stars, that has produced some of the most detailed images in the history of human science, and even it could not fully penetrate the dust shroud around 3I Atlas's core. Whatever is at the center of this thing, we are still guessing. What we weren't guessing about was the comet's behavior. The data collected when the comet was 277 million miles from the Sun shows that it had a dust loss rate consistent with comets that are first detected at a similar distance. In other words, it behaved like a comet, but with one enormous exception. The comet was from somewhere else entirely. It was wearing the clothes of familiarity while being something utterly alien underneath. The world watched as 3I Atlas continued its trajectory deeper into our solar system. It moved through space on a hyperbolic path, a trajectory that mathematically confirmed it would not slow down and stay. 3I Atlas is so fast it will escape the Sun's gravitational grasp. It is just passing through and will gain another gravitational slingshot from our Sun to send it on its way back into interstellar space, never to be seen again. Never to be seen again. That phrase carries a particular weight for scientists who understand its meaning. This was a once-in-civilization opportunity. Every second that passed without observation was a second of irreplaceable data lost forever. The entire global astronomical community mobilized. Hubble, the James Webb Space Telescope, ground-based observatories across the planet, ESA's JUICE mission, NASA's TESS satellite. It was the most concentrated observation campaign ever aimed at a single solar system visitor. Pulled by the Sun's gravity, 3I Atlas's speed increased to about 153,000 miles per hour at its closest approach to the Sun, known as perihelion, on October 29, 2025. At perihelion, this comet was closer to the Sun than Mars. Sun-warmed after billions of years in the frozen darkness between stars, its ancient ice began to sublimate at a furious rate. Gases trapped since the early universe were suddenly boiling into space, visible to every telescope pointed in its direction. And what those gases contained would rewrite what scientists thought they knew about the chemistry of other solar systems. Here's what nobody in mainstream coverage was highlighting in July 2025. The chemistry of a comet is not just a curiosity, it is a fossil record. The molecules locked inside a comet's ice are the same molecules that were present when that comet's home solar system first formed. When you read the chemistry of a comet, you're reading the autobiography of an entire star system, its temperature, its age, its elemental composition, what kinds of planets it built, what conditions existed there billions of years ago. So, when the James Webb Space Telescope finally turned its instruments toward 3I Atlas in August 2025 and began collecting data, scientists weren't just studying a comet, they were eavesdropping on the history of another world. As sunlight warmed it, 3I Atlas spewed gaseous water, carbon monoxide, carbon dioxide, and even metals such as nickel and iron. Iron and nickel boiling off a comet. These are not typical substances associated with simple cometary outgassing. But the real shock came later as the comet passed perihelion and began retreating back toward the outer solar system. That's when the deeper layers cracked open. That's when what was buried beneath billions of years of cosmic radiation finally saw sunlight. And what came out was not what anyone expected. For the first time, methane gas was directly detected on an interstellar visitor. Methane is an extremely volatile substance. Its appearance only after the comet passed near the Sun suggests the methane was buried beneath the surface, protected from warming and evaporation. As sunlight heated deeper layers of ice during the comet's close solar encounter, the trapped methane was finally released. Scientists were surprised by how much methane was present compared with water. Very few comets in our own solar system show a similar chemical makeup. This was not a subtle difference. This was a profound chemical signature that does not match anything we routinely see in our own cosmic neighborhood. But here's where it gets truly startling. 3I Atlas contained unusually large amounts of carbon dioxide, far more than typical comets formed in our solar system release relative to water. Our solar system's comets have a particular chemical fingerprint that reflects the conditions under which they formed 4.6 billion years ago. 3I Atlas has a different fingerprint entirely, and that difference is not noise. It is not measurement error. One scientist, Martin Cordner, an astrochemist at NASA's Goddard Space Flight Center, described looking at the data and realizing that relative to the solar system's typical comets and asteroids, 3I Atlas is Not just a little bit different, it's way different. When a senior NASA astrochemist says that, you listen, what most people are not seeing in this discovery is the deeper implication hiding beneath the chemistry. Astronomers didn't just find different amounts of familiar molecules. The exceptionally high deuterium to hydrogen ratio measured for this comet, more than 30 times higher than that of solar system comets, suggests that it formed in an environment significantly different from our own. 30 times, not 10% more, not double, 30 times the expected ratio. That number points toward a solar system that formed under conditions very different from ours. Possibly older, possibly around a different type of star, possibly in a region of the galaxy where chemistry evolved along an entirely separate path. We're not looking at a cousin of our solar system. We are looking at something that might be more like a stranger from a distant country, speaking a language we only partially understand. Webb captured detailed data, including chemical ratios of carbon and deuterium, also known as heavy hydrogen, that are not found in solar system comets. The results surprised researchers. And when you surprise the people who designed and built the most powerful space telescope in human history, who have spent their careers studying exactly these kinds of chemical signatures, you know you have found something genuinely new. Science, at its core, advances through surprise. And 3i Atlas was delivering surprise after surprise. The scientific conversation then shifted to something even more profound. Because comets are not just frozen rocks. They carry organic molecules. They carry the raw ingredients of chemistry that, under the right conditions, can eventually lead somewhere extraordinary. NASA's Dr. Stephanie Milam from the Goddard Space Flight Center noted, "Finding these rare isotopes is fascinating, but the bigger picture here is looking at the possibilities of prebiotic chemistry elsewhere in the galaxy. So far, we know of only one place in the vast cosmos where chemical ingredients led to life: our solar system, our Earth. Analysis of interstellar objects like 3i Atlas is, in her words, a major step toward learning how common or uncommon the conditions for the evolution of life are in the universe. Prebiotic chemistry, the chemistry before life, the molecular ingredients that, billions of years ago on our own planet, began the extraordinary cascade of events that eventually produced every living thing that has ever existed. And this comet might be carrying a version of that recipe from somewhere else. Think about what that means at its deepest level. If 3i Atlas formed around a star that burned out or died before our sun ever ignited, and if it has been carrying these chemical compounds across the galaxy for 11 billion years, then the question is no longer just where it came from. The question becomes what it was carrying, and whether those chemical compounds, those prebiotic building blocks found in compositions completely unlike our own solar system's comets, represent a different path that chemistry took in another world, a different experiment, a different outcome. Perhaps a different kind of life that we haven't even imagined yet. This is not science fiction. This is published, peer-reviewed, independently confirmed data from multiple instruments on multiple space telescopes operated by multiple space agencies around the world. And the scientific community's response to it has been extraordinary in its intensity. Since comets and asteroids are essentially material left over from the formation of a planetary system, their composition can reveal details about the conditions at the time. Studying interstellar objects like 3i Atlas is the best way to learn. About other star systems in our galaxy, short of sending interstellar missions to study them directly, we cannot travel to other stars. We do not have the technology. We will not have the technology for generations, if ever, but occasionally, rarely, the other stars send us something, and when they do, every telescope we have turns toward it. The comet continued to brighten dramatically as it approached perihelion. 3i Atlas varied in its rate of brightening, but exhibited a much steeper overall brightening profile than the previous interstellar comet 2i Borisov. From its earliest pre-discovery observations through pre-perihelion, it was more active, more volatile, more chemically expressive than anything that had come before it. ESA's JUICE mission captured dust-rich outflows and complex structural features within the inner cloud of gas and dust surrounding the nucleus, with active dust release and possible fragmentation processes occurring as the comet approached its closest solar encounter. This was not a quiet visitor. This was something that had waited 11 billion years, crossed light years of empty space, survived the gravitational tugs of countless star systems, and was now, in the warmth of our own sun, finally opening up. Hubble watched as another cosmic object, Comet K1, designated CEA 2025 K1, fragmented into at least 4 pieces while the telescope was observing it. The universe, in the same months it was delivering 3i Atlas, was simultaneously demonstrating how violent and unpredictable these encounters can be. Objects shatter, material disperses. The boundary between arrival and destruction is often razor thin, and yet 3i Atlas survived its closest approach. It passed around the sun and kept going, carrying its secrets back out into the void. By December 2025, as 3I Atlas retreated, the James Webb Space Telescope performed its most detailed chemical analysis. Analysis of data obtained as the comet left the solar system in December 2025 showed that it began emitting more methane after its close flyby of the Sun. The change indicated that it had shed its ancient outer layers and was now outgassing from its underlying layers, revealing its interior composition for the first time. This was the scientific equivalent of peeling back the outer layer of an ancient artifact to reveal what was preserved inside. The surface of 3I Atlas had been irradiated by cosmic rays for billions of years, and altered, processed, changed by the harsh radiation of interstellar space. But the interior, protected by that frozen outer shell, had been preserved since the very beginning. And what came out when the Sun stripped away those outer layers was a direct sample of the conditions under which an entirely different solar system formed. This was, in a very real sense, a message in a bottle, sent 11 billion years ago by a star system we will never visit, arriving in our neighborhood in the summer of 2025, and finally cracked open by sunlight and read by human instruments for the first time. What happens now? 3I Atlas has left our solar system. It has now departed at the same speed with which it arrived, something close to 137,000 miles per hour, and will never return. That object, carrying its ancient chemistry and its chemical fingerprints from another world, is now on its way back into the darkness between the stars. We will not see it again. Future generations will not see it again. It passed through the one brief window in which human civilization was capable of observing it, in the 1 century where we had the technology to analyze it, and we used every instrument available to extract every piece of data we could. Whether we extracted enough is a question that will occupy scientists for years. But what 3I Atlas leaves behind is more important than the data alone. It leaves behind a shift in understanding. If 3I Atlas is indeed as old as the evidence suggests, possibly 11 billion years old, it would mean that interstellar objects could have been easily formed early in the Milky Way galaxy's history, which raises an extraordinary question: how many of these ancient travelers have passed through our solar system before we had the eyes to see them? How many have crossed our path in the billions of years before human beings existed? And how many are out there right now, crossing the vast distances between stars, carrying their chemical records of worlds we have never named and never imagined? The answer, according to current astronomical modeling, is staggering. Scientists estimate that trillions of interstellar objects may be passing through our solar system at any given moment, most far too small and dark to detect with current technology. 3I Atlas was exceptional in its size and its activity, but it was not unique in its existence. It was simply the one we could see. And if the chemistry of 3I Atlas is representative, if its methane ratios and deuterium signatures and carbon dioxide composition reflect the kind of chemistry that exists elsewhere in this galaxy, then the universe outside our solar system is a place of extraordinary chemical diversity, not the uniform, predictable chemistry we might have assumed, something far more varied, far more complex, and far more mysterious. The real story here is not just one comet. The real story is what one comet revealed about the scale of what we don't know. For decades, humanity has looked at the night sky and studied our own solar system's comets and asteroids and used them to build models of how solar systems form, how planets develop, and under what conditions life might emerge. We built those models based on a sample size of exactly one, our own solar system. 3I Atlas is the most direct evidence yet that those models may be radically incomplete. The chemistry is different. The ratios are different. The history is different. The origin conditions were different by an order of magnitude. And if chemistry can vary this dramatically between solar systems, then our assumptions about where life can exist, what ingredients life requires, and how common or rare the conditions for life truly are, all of those assumptions need to be examined again. There is something almost haunting about this discovery when you sit with it long enough. An object formed before our sun existed, crossed the incomprehensible distances of interstellar space, arrived in our solar system in the specific decades when humanity had developed the technology to detect and analyze it, passed close enough to our sun to boil off its ancient chemistry for our instruments to read, and is now gone forever. The timing was precise to a degree that feels almost deliberate. A few decades earlier, and we wouldn't have had Hubble. A few decades earlier, and Atlas wouldn't have existed. A century earlier, and it would have crossed our sky undetected, unrecorded. Its 11 billion year journey witnessed by no one. But it came now. We saw it. We measured it. And what we found inside it does not match the universe we thought we understood. So here is the question that no one can answer yet. 3I Atlas was only the third interstellar visitor ever detected. The first was strange and unexplained in ways that still generate debate. The second was more familiar. The third was radically, shockingly different from anything in our own solar system. Each visitor has been more surprising than the last. Each one has revealed something the previous one did not. If this pattern holds, then the question is not what the next interstellar visitor will look like. The question is whether we will be ready for what it tells us. Because if a comet from 11 billion years ago, from a solar system that no longer exists, can carry chemistry that shocks senior NASA astrochemists and produces data that no current model fully explains, then what is the fourth visitor going to carry? What chemical message, what ancient record, what fragment of a world we cannot imagine is already moving through the darkness between stars, already aimed in our direction, already on its way? The universe is not finished talking. We are only just beginning to listen.